Got a mic. Oh, that's... If you want to, let's talk into it. Right. Good evening, ladies and gentlemen. Thank you very much all for coming to our TechHub Google Cloud Platform talk. Still too much of a mouthful. I'm Phil. I'm the Community and Events Manager here. And this is Levi.
Hello. It's nice to finally see all the faces in one room that I keep passing on the stairs. I'm the new community manager here, joined a week and a half ago. So do come and introduce yourself to me. I'm going to be planning lots of events, so let me know what you want to see from TechHub. So yes, you're all very excited about the Google event, so I'm going to ride on those wings and go straight in with some health and safety for you guys. Fire alarms. There aren't any planned evacuations this evening, so if you do hear a fire alarm, just head straight out that door into the stairwell. Resist the temptation to pop in for another drink into the office. The meeting point is by the Adelphi, so we can crack on with that there if needs be. Toilets are first door on the left here, so they are unisex, just in case you have any frights. Can I just have a quick show of hands who hasn't actually been to TechHub before? There's a few faces. Fiona, I spoke to you earlier. So yeah, I just want to give a very quick overview of what we do here at TechHub. So on this floor, the second floor is the main TechHub floor. We've got a number of our startups working there. In total, across all 4 floors, there's 120 of us involved. On the first floor, we now house our hack space. They were previously in a tiny little cupboard up on the 4th floor. They've now expanded to the first floor, and they're 25 members strong and growing. And they've got open nights on a Monday, which I really do encourage you all to do, because I went along last Monday, and it is really, really great. Phil came along with me, and they've got lots of exciting workshops lined up. On the 3rd floor, we've got the DVLA at TechHub. Lots of faces here from the DVLA. Amazing to see you all. 4th floor is another one of our startups, Vico. They've outgrown this floor and taken over the whole of the 4th floor, and they're a great bunch of guys. We have got Jamie, who is, don't look now, filming you all. He works at Vico. So yeah, there's loads of us here from TechHub on all the floors tonight. So if you do want to ask any questions, talk about any projects, Fiona, I spoke to you earlier. There's a few faces here that I've seen. I'd love to chat to you all. Paul stood here looking suave against the pillar. Come and chat to us all. Yeah, we'd love to work with you, plan events, anything you want. Come and give me a chat. I'll hand you over to Phil.
We have got a Twitter hashtag tonight, so if you can get your phones out if you're on Twitter. The hashtag is THGHack. Any photos, just any questions, anything you want to put up, fire them up on Twitter. That's fantastic. I don't think what else I have to say. That's about it. Other than that, we'll hand over to Robert from Google, who's going to talk about the cloud platform. Thank you.
All right, thank you for the introduction. I hope we don't get anything on fire here during the hack or during the talk. I want to check in the beginning, like, how many of you are developers here? Okay, that's a good crowd. So this will be a developer talk. The first one will be actually an introduction, so it will be an overview what is part of the Google Cloud Platform. I will put in some demos here and there to showcase it, and then I have actually 2 parts of the Google Cloud Platform, 2 products, where I can do a deep dive, a technical deep dive, which would be the second talk coming up afterwards. We will in between have a little break. So I will put up the vote for the 2 talks at the end of this talk. So be prepared. All right, a little bit about myself. I'm Robert Kubis. I'm a developer advocate at Google for the Google Cloud Platform. You find me in London. So I came here today actually from London. When I'm not in London, you find me definitely on Twitter and on GitHub, so feel free to follow me or ask me any questions through these channels. Okay, if you hear of Google, or many of you and I, in the beginning you look at like a web page, it has a logo, a text box and 2 buttons, and you type in some text and a couple milliseconds later your search results come up. If I think of this, I think of actually data centers, network, global distribution, global availability. So how did we get there? So when we started actually, roughly 15 years ago, even more than 15 actually by now, the technology wasn't there. So a lot of the technology, a lot of the network technology, the infrastructure, connectivity between data centers, we actually build ourselves. And by doing this, Google has now one of the fastest and most powerful and highest quality networks and cloud infrastructures in the world. All right, so if you look 15 years back, that's how it looked like 15 years back. Not as tidy and clean as the data centers today. But building all this enabled us actually and our developers to be innovative. So we had to build an infrastructure where we could scale, an infrastructure where we could innovate in products. And this infrastructure actually powers today many of the Google products, actually all of the Google products. If you look at it, Gmail, Maps, Google Drive, or the Android Play Store are like running on this hardware, and we didn't want to like keep that to ourselves. So what we did is actually, or what we continue to do, is bringing these advancements that we made there to you in form of products of the Google Cloud Platform. All right, what's the Google Cloud Platform? Let's start with computing resources. So this goes from infrastructure as a service, where you basically have your VM, your virtual machine with your favorite operating system, up to platform as a service, where you basically bring your app in your language that you wrote and you just push it to us and we take care of it. It also involves storage, which goes from blob storage, where you can drop assets for the Google Cloud Storage, or we also have a managed MySQL version. We have a data store and Bigtable. Bigtable is a key value store, which is actually driving Google Search. We also have tools for big data. So here you see BigQuery, Dataflow, and Genomics. And actually one is missing, but anyway, you will see it later. We have as well tools for, there it is, for connectivity. So basically, if you spin up your virtual machines, if you want to do load balancing, or if you want to connect your on-premise data center or infrastructure with the Google infrastructure, we offer VPN, we offer cloud endpoints and stuff like that. All right, so this is great. It's a lot of products, but if you want to build actually your product in Google Cloud Platform, you want to be supported, and we actually don't stop there. We actually support you by giving you developer tools, SDKs for multiple languages. We help you and give best practices out there to get you started and get you to a scale. We also offer, once your application is running, you want to be able to, on the one hand, monitor your application, so being able to be informed if anything goes wrong. On the other hand, if anything goes wrong, you want to have the facilities to dig into what's actually going wrong. So we have cloud monitoring and cloud logging. Last but not least, we are a mobile-first company by now, and mobile is everywhere. So we also have offerings in the mobile space, one being the test lab, where you can actually test your Android applications on real physical hardware. And another one is Firebase that we acquired in October last year, which is a real-time database which you can access directly from your clients, from being an Android or an iOS phone or a web application. All right, so let's start with our compute resources. As I mentioned in the beginning, so it starts at infrastructure as a service. So if you have, for instance, an existing workload which is running on your laptop or on your in-house data center or on some hoster where you have virtual machines, you can migrate them to us. So that is basically the basic entry level. You get it with your operating system of choice. We are available in 3 regions, so in the US, in Europe, and in Asia. It's backed by a fast software-driven network. And the data centers, the Google data centers are actually connected by dedicated cables underwater and over land. So there are low latencies between the data centers. We have sub-hour billing. What that means, basically, if you spin up a VM, the first 10 minutes you pay, and then you pay every minute. And if you have continuous use of your virtual machine, we actually give you a rebate as well. and they are consistently fast. So our infrastructure ensures that you are shielded from noisy neighbors. So if you order a VM from us with certain specifications, CPU and main memory, we make sure that you actually get that and are not like interfering with any of your neighbors. So on the instances size, what we offer is shared core up to 32 cores instances and up to 208 gigabyte of RAM instances. There are like different configuration. There are high memory or high CPU configuration, so there are a lot of choices. You can also put your favorite operating system on there. So be it Debian, be it CentOS, Red Hat Linux, SUSE, CoreOS. There are a lot, even Windows in beta right now. If you spin up your virtual machine, you of course need also a disk. We have 3 choices of disks that you can attach to your virtual machine. Starting with the standard persistent disk, which gives you 2 IOPS per gigabyte. So basically, if you have a 100 gigabyte disk, it gives you 200 operations per second in speed. If that's too slow for you, you can attach an SSD persistent disk, which is not local. It gives you up to 15 times the speed. And then if that's even still too slow for you, you can attach up to 4 local SSDs, which have sub-milliseconds latencies and give you up to 1.5 terabyte of space. All these persistence disks and also the virtual machines are supporting live migration, which means basically if we do any data center maintenance, we live migrate your virtual machine as well as your persistent disk. So you will not feel a huge interruption, very, very little interruption, and you don't have to take care of any of this. Another great feature, especially in Europe, all the data is encrypted at rest. All right. Now how to get started with Google Compute Engine. It's very easy. You sign up. We have a free trial for $300 cloud credit for 60 days. You sign up, you create a project, and you don't download the G-Cloud SDK from Google. And then it's basically 3-4 steps. You can actually put the second and the third in one to get started with a virtual machine. So you log in, it opens a browser window, you just say like, yeah, accept. Then you set the zone, basically Europe, Asia, or US. You tell it like what project to use. And then basically G-Cloud Compute instances create, demo 1 creates your virtual machine in about 30 seconds, it's up and running. And we make it also very easy to log into these machines. So basically G-Cloud Compute SSH and the name of the virtual machine, and we do all the provisioning of the SSH keys. All right, sorry. So I want to drop in a little story here. Before I joined Google, I worked for a Fortune 500 company, and I was tasked with writing a web application which was shown at the global all hands. So at that time, we had about 60,000 employees. Of course, not all employees going to global all hands. But I couldn't really estimate what would the traffic look like, right? So what do you do in this situation? And I actually at that point did that with VMs. What do? You actually go like, okay, I want to have a safety margin. So I take a big ass machine basically and want to be on the sure side that I can cope with the traffic that might come or not come. What does it mean? In the end, it basically means that you have a lot of resources laying around for a long time, because the global all hands that happens at a certain time for a couple hours where there could be a lot of traffic, but basically before and after that, it's very unlikely that you get that spike of traffic again. So you build up a big machine, and 99% of the time it's basically idle. And the other thing is also I had to do all the management of setting up the database, always releasing a new version of my web application and all the DevOps. So I spent in the end 30-40% of my development time I spent actually in DevOps, which is basically lost time in innovating and creating your application. And a lot of companies feel the same, and they want to do something else. So if some of you might recognize here, Snapchat, Ingress, and Khan Academy, they don't want to spend a lot of time in DevOps. They want to use their development resources to innovate, to build great apps. So that's where Google Cloud Platform App Engine comes into play. App Engine is a platform as a service. So it gives you a choice of runtimes, Java, Python, Go, and PHP, and we also support custom runtimes now. It's very easy to develop. So you can develop your application locally, you can test it locally, and you can actually focus on your application code and then push it out, and we take care of everything else. So we take care of scaling, we take care of patches underneath and updates. We have a team of site reliability engineers at Google that watch App Engine and make sure that it's running. So you don't have to care about like any of the DevOpsy stuff other than developing your application and pushing it to the cloud. So right here, I want to stop and actually show you how easy or how little of code you actually need. So we have here, I choose a Python application, and I hope you can read that. So I want to ask, like, can you read that in the back, what's shown there? Or should I? Yeah, it's good? Okay. So basically, what do you need for developing and deploying an App Engine app? It's basically, you have the application name, which corresponds to your project that you created in Google Cloud Platform. You have a version of your application, a runtime, an API version, which is basically the API version of Google that you're talking to. You declare if it's thread safe, and you define a couple of handlers, so entry points basically in your application. So nothing magically here. The other thing is, I want to have a little Python app. So what I did, I choose the web app 2 package, and I wrote a little request handler, which basically, if it gets called, it gives me a JSON back with hello Swansea. All right, so I want to test that locally. So I use my dev-app-server.py, which comes with an SDK that you can install for Google App Engine. So that will start up a local server for me. And let's see if that works. Okay, no magic, I will do a hard reset. It actually works. Okay, so this is my local. So it seems it works, it looks good. I'm happy, so I can actually stop this and say, all right, now I actually want to push it. So I use app-cfg update and same folder. So this actually pushes us now to Google App Engine. And then while it's doing this, I can actually do that, and we wait for a couple seconds. All right, and you see it works. So that easy it is to actually push an application to Google App Engine. All right, so I mentioned that we have, on the one hand, curated runtimes where you can run Python, PHP, Java, and Go. We also have so-called managed VMs where you can bring it's basically containerized environment where you can build your own container with your choice of runtime and your choice of libraries that you want to package with it. And then we provide a couple of hooks so that we can manage your, or you have to provide a couple of hooks that we can hook into so that we can manage your container. Show that. So now if we look at these two compute resources, on the one end, we have compute engine with very high flexibility, but lower developer efficiency. So you have to take care a lot of yourself. You have to do the updates. You have to do the installing of all the packages. On the other end, we have App Engine, which has a high developer efficiency, but little lower flexibility. So you have to comply to certain restrictions that the App Engine puts on you. So we want to get in the space where we have high developer efficiency and high flexibility, and that's where Google Container Engine comes in, a Docker or a container-based management system, and this is based on Kubernetes, which is an open source project inspired by Google with our experience in running containers. And before I say too much, actually, this is the deep dive topic number 1. So if you want to hear more about Google Container Engine, vote for Google Container Engine at the end. All right. That be it for now for the compute resources. Second is storage. As mentioned in the beginning, we have blob storage. Oh, sorry. We have blob storage, managed SQL, and data store. So our blob storage is Google Cloud Storage. You can save up to 5 terabytes per object in this store. We have 999 SLA for this. It's encrypted at rest. It's globally distributed and replicated. And it has a very strong read after write consistency for all the objects. And it also supports so-called change notification or object change notifications. Google Cloud Storage has 3 options in terms of the quality and, for speed and availability. So the standard storage is our fastest solution. And then we have a second option, which is durable reduced availability storage, which takes a little bit away from the speed. So basically throughput, what you can load and push data, and also a little bit on the availability. And availability in terms of when do you get the first byte after you request an object. The third one is nearline, and so nearline is, again, we're cutting back on speed and we are cutting back on availability by reducing again the replications or the replicas of the data. But this is especially targeted at backup solutions. So nearline is not good to use if you read your data more than once in a month. It gets actually more expensive than durable reduced availability storage. What you want, if you like, nearline is really to replace the old tape backups. And the amazing thing is with nearline, you can get data in a couple of seconds to a minute for your first byte. Do that or try that with a tape backup. All right, I want to dive a little bit into object change notification. What does it mean? So Google Cloud Storage supports resumable up and downloads. And if you want to decouple your application from any kind of file or asset management, what you can do is you let your client do the upload to your cloud bucket, and you register actually a notification hook where, like, here's the command, you register a notification hook, you give basically the endpoint where the notification should be directed to and the bucket name or the bucket location, and you can also use subparts of your bucket. And anytime anything changes in this bucket, a notification is triggered and sent to that endpoint that you have down there. So you're registering it. When a client updates or moves or adds an object, this change notification gets triggered. And it's basically a simple HTTP call with a JSON object, which gives you information about the object that was added, removed, or updated in the bucket. All right. Another cool feature that we offer with Google Cloud Storage is edge caching. And you can set the caching directives on the object when you push it, so to like how long it should be cached, if it should be cached at all. And in terms of like, if it's, we try our best to basically serve the assets closest to your users. We cannot guarantee it, but depending on like how many users are in a certain region requesting your assets, we try to be as good as possible. The second offering in storage is Google Cloud SQL. It's a managed MySQL, currently in version 5.5 or 5.6. So it's fully managed. We're doing patching and updates and everything. You can choose the instance size that you want to use. We use automatic encryption and replication, and we also offer REST API for administration. The third offering is Google Cloud Data Store, which is a NoSQL-based database. It has, again, also a REST JSON API. There are open source lines for it and also community-maintained object relational mappers, which you can use to access Data Store. It's well integrated with Google App Engine as well as Google Compute Engine. It auto-scales with your need, so you don't have to pre-select the size of the instance that you need, so it basically scales on demand. And it also supports atomic transactions. All right, so this should be it for on the storage side. Now, the next category where I want to dive into is the big data, and there specifically into BigQuery. So BigQuery is a amazing, crazy analytics tool to crunch tons of data, and I will show you in a second. So you can analyze and crunch terabytes of data in seconds, and it supports an SQL basically a subset of SQL. And all the data is replicated and encrypted again, and we spin out. It's again a service on demand. So we make sure that you have the resources that you need to crunch your data, but you don't have to define upfront like how much you need. Basically, you pay on like how much data you process and not on how much data you store. All right, so we have public data sets in Google BigQuery that everybody can play with. So if you sign up for the free trial, you create a project, then you will have an option there to BigQuery, and you will see the public data sets. So one of the questions that I want to ask this public data set in a minute is, what's the most productive day in the week for Wikipedia contributors? So let's do that. So I go to BigQuery, I'm logged in, I have my query window here. As I mentioned, you have the public data sets, so we have Wikipedia down here. You can look at the schema of that data set. And now, basically, I do select. I say, OK, I want to transform the timestamp of any changes on Wikipedia articles to a day of a week, starting Sunday. So the Sunday is 1, and then Monday 2, and so on. And I want to count how many changes were made on that day. So I group by that day, and I also sorted in descending order. So let's run this query. Actually, I don't want to have it cached, because that could be cheating. All right, so I want to do this, and let's see how long it takes to run this and how much data it processes actually. That's long, usually what's happening. That's the demo effect, and the demo gods are not good with me today. All right, let's abandon that. I'm sorry, let's try this again. Let's see if there's, here we go. Okay, so we basically have 2 seconds for 2.34 gigabyte. Well, it's great, but it's not very impressive. Let's look at some other queries. So the next query that I want to look into is, I want to actually see how many page hits we had for Wikipedia for the second, third, and fourth quarter of 2014. And let's take out 2015 for now and stay with 2014. So that's basically, except for the first quarter, and April is also missing. We basically have 8 months here of Wikipedia page hits. So let's see how many are there running actually, or how much data do we have to crunch, and how long does it take? Let's cross fingers for the demo gods. This is supposed to be a little longer, but I have a bad connection today. This is taking long. I don't know if it might be that the US woke up. But we're looking here at 25 seconds. So usually when I tested it earlier today, it ran about 10 seconds. And look at the data it processed. It almost processed a half terabyte of data. And even though it's like twice as slow right now for the demo, processing like 338 gigabytes of data in 25 seconds is freaking amazing. At least it's mind-blowing for me. All right, so like this query, it is a sum, and it's basically collecting from a table. So it's nothing sophisticated if you look here. And so if you look at it, it's like, okay, you probably get like, if you get like a really big setup of the best relational database on the planet, I don't know who that is right now, and the whole data set is in memory, you might get similar times. It's basically a table scan what we do here. So I want to do a little bit more sophisticated queries. So what I'm actually going to do here, and that is a data set, again, from my colleague, Felipe Hofer, who is our BigQuery expert. So I want to explain that a little bit. So what I get here is I want to have the 10 most prominent women by location in May 2015. So what do I do here? I basically go in the Wikipedia page counts dataset again and look what page was brought up, like how many times. And then if I do that, I don't really know, like, okay, the one thing is what I want to add to this dataset is I want to know where they are actually from. So this data is not necessarily in Wikipedia in a structural form. So it might be in the text, but it's not in an easy accessible form. But there's something, Google acquired that company as well, it's Freebase. Freebase tries to get the world data into a more accessible format with metadata. So we're actually joining here with Freebase and look at, like, okay, the gender, what's the person's gender, and also where is this person from. So let's run this query. Oh, thank you for spotting that. You probably saw that for a long time. It's like, all right. Thank you. All right, so let's run this and see, are we running end of file? No, it's running, okay. So it must be the US that woke up and is doing a lot of crunching. But you see here, we're actually doing 2 joins. We're doing inner selects. So this is actually a sophisticated query that we have here. And we're processing 330 gigabyte of data in 12 seconds, right? So if you look at the simple, like, table scan that we did earlier, and this, like, complicated query, this one is even faster, right? So this is mind-blowing, at least for me. Gets me all excited. Okay, so for this one, I actually had my backup. So I will gently scroll through it. Another thing that I want to look at in this overview, and I hope we are still good in time, yeah, it looks good, is Firebase. So we acquired Firebase in October last year, in 2014, and Firebase is a NoSQL real-time database. So it helps you to develop mobile application and keeps your applications in sync, be it an iOS, an Android, or web application. It also supports you. It's basically, you don't care about backend anymore. You build your applications directly on your clients, and the backend is taken care of for you. So this is falls into the category as backend as a service, which is even one step higher than an app engine where you have platform as a service. Other features that Firebase supports is user management and hosting. So I will again go into more details if you choose to get to know more about Firebase. So at that moment, I actually want to ask, like, how many mobile developers do we have here in the audience? 1, 2, 3, 4. You Google, you don't count. And how many DevOps, like who is playing with containers and VMs? You count again. Okay. All right. So that will be a close run then. There's no, like, a lot of favoritism for one of the other talks. One last note that I want to make before I close this talk is we are environmental responsible. So we aim to power all our data centers with renewable energy. And we invest a lot of money into building wind power and other things to be certified as 100% carbon neutral. All right. Yeah, hackers and goodies. For all the ones that are joining the hackathon, we have a $200 cloud credit that everybody will get, and give up a sign-up sheet later for all the participants. And we also have a prize for the winners, which is an additional $1,000 of cloud credit so that you can play. The $200 is valid for 6 months, and the $1,000 is valid for 1 year. So it gives you a year to play around with it if you want. All right. So we have these 2 deep dive talks. I want to see like showing of hands. So I forgot my cloud clap meter at home. So like voting with your feet will not do anything, unfortunately. So please show your hands. Who wants to see containing chaos with Kubernetes. All right. You only have one vote. Okay. Who wants to see Firebase mobile application? All right. That I would say that is for Kubernetes. So I will, after a short break, we will give a talk or continue with a second talk about managing Docker containers with Kubernetes. All right. Yeah.
Right, if you want to go get some more food and drinks, please feel free. We'll be back in here in about 15 minutes. Big data stuff. Hello again, everyone, and hope you're all suitably refreshed now. We've got another demo first, and then into App Engine.
Yeah. All right. Let's do the demo first. All right. I actually, like, in all the excitement of the first talk, I forgot to show like how App Engine can scale to your workloads. So one of the things is I have a visualizer here. Let's see if we can find it. All right. So I'll actually reset this, and I hope the space is enough here to show this. Window management, difficult here. All right, so I didn't clean up my playing current up front, so let's do this first. Okay, still log in. Okay. So what you see here is basically we have a bunch of compute engines that I will start up in a second. These compute engine instances will be used to generate a load against an App Engine app. This App Engine app is already deployed, so it's actually under this URL. So I just go there and show what it's showing up. It's basically just giving a JSON document. No, it's not even a JSON document, but some data, basically what we are returning. So let's see. I hope it's done. So actually we'll start here these 10 machines, and that should take about roughly 30 seconds to come up. So you'll see in about 30 seconds the 10 machines slowly coming up. You see also out down here we have one instance right now running for the Google App Engine. So we didn't do anything special there. We just deployed our app to App Engine. And as soon as I hit that endpoint, which I just showed a second ago, this instance will be started. If this instance is idle for like amount of time, like 10 minutes, it will be shut down. So you can actually scale down to 0 instances with App Engine, so it doesn't incur any costs. So we see here now our 10 machines actually came up. That's great. So now I want to load them, and the command that I execute right now is actually will be firing 1,000 requests per second, so 100 requests per node per second, and that for 10 seconds. So I do slow typer, I'm sorry. 1,000, 10, 10. All right, so let's see if that works. This will be pushed, and we see here, that's how fast App Engine scales, right? So if you compare that, if you build your own auto-scaling with VMs, and you compare that like to auto-scaling which we manage with App Engine, that's the difference. All right, so that being shown, and we are soon up to 10,000. We don't have to show that till the end. My next talk will actually be desired state containing chaos with Kubernetes. So I mentioned already Kubernetes is an open source project which is inspired by Google, and it's actually put in a compute foundation. So before I start and diving into Kubernetes, I want to actually track back a little bit and start at a different level. So if you look at the continuum of between agility and flexibility for development, you have on the one hand what we have just seen, virtual machines as infrastructure as a service. And on the other hand, you have platform as a service, which I just showed, App Engine. You basically have created runtimes, you push your app code, auto-scaling and managing is taken care of for you. On the VM side, you basically have to take care of patches and everything. So what fits in between there? And what fits in between there is actually a cluster where you manage containers, which gives you, on the one hand, the flexibility from virtual machines to the most extent, but also the speed and agility of development of platform as a service. So what is a container? If we look back in the history, like 10, 15, 20 years ago, right? If you develop an application, web application, usually you had a physical machine, you put your app there, and usually if you're in a company that has to save money or doesn't serve a lot of traffic on one app, what you did is you put a lot of apps on one machine to like utilizes to the fullest, let's say it this way. What did that mean? Basically, if you want to do updates, you have to test all these apps again. There are a lot of point of failures for this scenario. And you have no security isolation whatsoever between these apps, or very limited. So the next step was going and putting in some isolation by virtualizing physical hardware and putting virtual machines on top. So you take your your physical environment and put it in a virtual machine. It looks very, very similar, and you can actually put one virtual machine per app. So you actually have some isolation, but it's very inefficient. So each of these virtual machines runs a full-fledged operating system, right? So usually most of your memory and space, what is consumed, is actually consumed by your operating system and not by your application. So, and it takes away from resources of your host machine. And the other thing is also it's hard to manage. So the new way of doing that is actually to take the lightweight approach, and that is using containers. Containers shares the underlying operating system and the kernel from this operating system. It allows you isolation, and it allows you a very quick way to spin up new so-called container instances. So if you look at a concrete Docker example, Docker is one of the container formats. It's the most popular container format out there, and if you want to look at a concrete example of that, it's basically you choose an operating system, so to say. If your host system runs the same operating system, and many of the libraries is basically taking that and sharing this. You have a layer of libraries that you need for your application. You put a PHP or Apache, and then you put your application on top. And while you're building this Docker image, you're basically downloading and packaging all these libraries and your application code into that container. You bake it at the time of building it. All right, so basically that is your state that you package and that you push to Docker Hub, which is a share place for Docker containers, or you have your private container registry where you can push containers. So now when you actually run Docker containers, what happens, it takes this container, which has a defined state in terms of it's a read-only file system with all your application code and your libraries, and it will put a read-write file system on top of it. So basically, if you run your container and you do certain things, it only changes elements or files in that read-write system. As soon as you stop that container, you have to choose if you want to persist that read-write layer, but usually that's thrown away. And the next time you start your container again, you start at the exact same state as you pulled down the container the first time. So that gives you a lot of repeatability. It's also started with kernel restrictions, and yeah. Okay, so for basically, if you look at an application where you have a PHP app, maybe your PHP front end, you have a memcached as your cache, and you have a MySQL as your persistence layer. So all of these share a common operating system. So in this case, we share all of them, share Debian as a common system. Then MySQL has a set of libraries and the MySQL server running. And you have for your memcached and your PHP Apache, you have certain libraries that are shared and then some that are distinct. So basically when you run and start that Docker example, that Docker container, the libraries that are shared are actually shared by these running containers. As I said, that are read-only states of these files, so they can be easily shared. Okay. The amazing thing is if you look at Google, everything at Google runs in containers. If you look at Gmail, at Web Search, at Maps, at the Android Play Store, even the VM that you get from us for like our infrastructure as a service offering, it runs in a container at Google. And the mind-blowing fact is actually, and I want to put that as a question here, like how many think that Google runs more than 100 million containers a week? 1, 2, okay. Who thinks more than 1 billion? Okay. Who thinks more than 2 billion? Okay, so Google actually runs more than 2 billion containers every week. Starts and stops more than 2 billion containers every week. All right, why are we doing this? A lot of the things I mentioned already. So one is performance. So basically, it's very quick to spin up containers, right? So you have a shared file system, so you can spin up containers in a matter of seconds. The other thing is repeatability. So it doesn't matter where you spin up your container, it always starts at the same state. So you also, yeah. The other thing is quality of service. You can actually define how much resources this container consumes. So you can restrict the CPU and the memory consumption of this container. And that gives you also the possibility to actually account for the resources that are actually used by your containers. So you can use that to see like if anything goes rogue or not. And also most importantly, portability. So if you look at like a development cycle from your applications, if you develop your applications with containers, it's possible to run your container locally on your Mac, or you run it in a data center, and doesn't make a difference. So it gives you a very nice way from going from development through staging, testing, staging to production. So if you look at it, it's a fundamental different way of managing applications, because you package all your libraries and dependencies that you need for your application at the point of time that you build your container. So you make sure all these libraries are available. So at the time that you build your container, you can make sure that it actually works. And at the point you deploy it to your production, there are not, like, these dependencies are not relevant anymore.
Thomas, you can ask questions at any point.
Sure.
Can you just describe what you mean by quality of service in this context?
Quality of service?
Yeah, in the coding context, what do you mean by quality of service?
Quality of service. So basically, it's really about that you that you can make sure that you can. So if you look at, like, you can define the resources one of these containers can consume, right? So you can make sure that these resources that a container consumes is actually available at the point that you deploy it. So you can make sure it's like if you say it gets 3 CPUs and it gets 2 GB of RAM, that this is available,
So
right?
take response time,
No, that would be on a different level. Yeah. Okay. All right. So if you look at Kubernetes, let's take an example application here. We have a guestbook. And that guestbook, everything what is posted to this guestbook is persisted in MySQL. And if somebody looks at the web page, we want to cache the entries actually, and we use a memcached for that. And because our guestbook app is so popular in Swansea that like hundreds and hundreds of thousands of people are actually going to our guestbook app, we want to be able to scale the front-end layer. So we want to scale the web server that runs our PHP application. So what are the challenges here? So I have a bunch of machines. So on which host machine are I running what, right? So how does my PHP find the memcached? How do I keep all of these running, right? What is like if something drops that basically one of my front end like services like falls apart? How do I keep everything running? How do I keep serving my users? And what happens if anything is in trouble? So I want to keep the whole thing healthy and I want to make sure that it's done. So that's where Kubernetes comes into play. So Kubernetes is Greek for helmsman. So basically a container orchestrator that runs Docker container, and also there is in the works to run other container formats. And it supports different clouds, so you can run it on like most of the big cloud providers. It also supports bare metal, so if you have your in-house like a couple Raspberry Pis laying around or old notebooks on old PCs, you can basically transform them and build a Kubernetes cluster out of them. And as mentioned, it's inspired by Google's experiences running containers. So yesterday when I took this screenshot, Kubernetes had about 10,000 stars on GitHub. That's a very, very lively community around this project. And there are very big players that are actually contributing to this project and making sure that it runs on their infrastructure and enabling a lot of people to actually move easily between cloud providers. So the title of this talk was Desired State. What does it mean and like how does it play? So we come back to desired state as a way like, okay, I want to describe how my application is running or like what my application should do, not describe where it should do it. So there are 4 concepts within Kubernetes that help me to describe a desired state. First concept is pod, which is a tightly coupled unit, atomic unit, which is traveling between your Kubernetes nodes. You have basically in this pod, there are containers coupled, so you can run multiple containers in a pod. You have the replication controller, which is watching these pods, and that is basically looking for like your desired state, like what do you want to have, how many pods do you want to have, and run these. We have services, which are basically load balancers. So if you have a lot of pods, like identically pods running, the service creates an outside interface or IP for these pods and load checks on the health of these pods in terms of if anything is not healthy, it doesn't direct traffic anymore to there. And labels is metadata, which helps you to organize all these elements in Kubernetes. So pods, small Kubernetes containers of volume. So in this example, for instance, I have 2 containers, one a site generator and one a web server. So the site generator basically looks or watches some bucket or some destination where like it could be, for instance, a Git container which watches a repository, and every time a repository changes something, it will update the local file system for that pod, and then the web server is serving this. All the elements or all the pods in that, all the containers in a pod share an IP address, so you basically can communicate on localhost within a pod. Another thing, they're ephemeral, so they can die and can be replaced and rescheduled at any point in time. Okay, the application controller is basically you define a desired state. It's observing that the file is the like actual state right now. It's taking a diff to the desired state, and then it's acting upon it. Basically, depending on if you have too many pods or too few pods, it's either like creating new ones or killing. So an example for this is, for instance, our desired state is 6 pods of that pod with the couple of containers in there. And now, like, let's assume this node 2 there is, I have set this up in my living room, and I have like 4 Raspberry Pis, and sometimes I'm a little clumsy and like I rip out the network cable. So the pod goes, like the node goes away. So now we actually have 4 pods only running. So the replication controller very quickly realizes, okay, the desired state is 6 pods, so I should schedule 2 more, and it's scheduling that on the remaining nodes that are still alive. So now I realized that the network cable was unplugged, so I plug it back in. And the node comes up again and is integrated into that cluster again. So now the replication controller realizes, oh, now I have 8 pods. That's way too many. So I'm actually stopping 2 of the pods on my nodes and go back to my desired state. All right. So services give these pods that you're running, if you're running 4 or 6 pods or whatever number you want to have, a stable IP address. So you basically can connect to that IP address, and it does a round-robin load balancing. It's also watching these pods if they are healthy, and it's basically a construct to hide complexity. So the other construct in Kubernetes is labels, as mentioned before, and labels are actually used to like for services and for application controllers to find the pods that they are responsible for. So here you have, for instance, 3 labels that we defined. We define an app, we define a phase for these pods, and we define a role. So we have like a front end and a back end role, we have a testing and development phase, and we have a guestbook and an encoding application. So if I do a single selector on app is guestbook, then I get these 4 pods. Now, if I do on a role and say like I only want to have my front-end pods, I get only the front-end pods. But I also can, of course, concatenate these labels and say like, okay, I want to have all back-end guestbook apps, and it only gives me a subset of the pods. So this helps you to manage your pods and allows you to actually take out pods and put in arbitrarily. All right, so the scheduling of pods is very basic at the moment. A lot of the big companies that are involved in Kubernetes are actually right now developing more sophisticated scheduling algorithms, but right now it's basically looking at like how much resources do I have at the nodes of my cluster, do I have enough resources to schedule that pod on, and then basically doing like, okay, where is the most available space, and then I schedule my pod there. So if we look at our example app from the beginning, our guest app where I have the front end, and my MySQL persistence, and my memcached, how would I do that with Kubernetes concepts? And I would basically create a pod for my MySQL, which is attached to a persistent disk, and I put a service in front of it. I also use my memcached and put a service in front of it so that I have the stable IP, because anytime when my memcached, for instance, is rescheduled, it could get a new IP, and the service makes sure there's a stable IP for the other elements of the application to talk to. And I use a replication controller for my front end, which always like makes sure that I have enough pods of my front end running. And again, in front of this is a stable IP, and for this one, even an external IP to access this guestbook app. So with this said, I actually want to demo it. So I hope the demo gods are still good with me. So let's start this. So this is actually, I have to change the size again. So this basically is a web page which shows like all the elements in my cluster that are starting or stopping or what state they are in. And I start with, so I basically have a couple of configuration files here that describe my system. So I want to start with my MySQL server, and I want to show you actually how that looks like, how such a configuration file looks like. So is this big enough? Can everybody read that, or should I try to make it bigger? I'm not sure if that helps. All right. So basically, again, API version is the Google API version that we are talking against. So we use Google Container Engine, which is a fully managed Kubernetes cluster in this case. And the API version that we are currently using is V1. So I'm describing a pod here. I'm putting a name down for this pod, in this case MySQL. I'm attaching labels to it. So on one hand, I'm attaching the name label and I'm attaching the visualize true label, which basically tells my visualizer to pick up that pod. And for the specification of that pod, I'm saying like, okay, I want to run in a container. In this case, it's MySQL version 5.6. I give it half a CPU. And I define a couple of environment variables. So here, for instance, my super secret password, root password, and the container port and things like that. Another thing what we also declare is the volumes to mount and where to find them. All right, so I can start up this. So there's a tool that comes with if you install Container Engine, the Container Engine extension for Google Cloud. There's a tool called kubectl, which is basically your magic wand with Kubernetes. So in this case, I start my MySQL server, my MySQL, and you should see, okay, and it's coming up, and it's yellow because it's basically pending and starting and finding the disk, and yes, that takes a couple seconds. Next, I want to have a service, so I also start a service. So now you see MySQL is up and running. I started the service, which gives me, in this case, this is a cluster internal IP. So now services within that Kubernetes cluster can access this IP, and there's a kubedns running, which can actually does the name resolution. So you actually can call it by name or domain name, basically, inside that cluster. But this is not externally accessible, which is good because I don't want to have everybody like accessing my MySQL database and everybody knows my super secret password now. So it better doesn't. So the next thing that I want to spin up is my memcache D. So again, very similar. So I don't want to show it again, or I will not show it again. It's basically again saying like what container image do I want to run, how much resources do I want to give it, and again I'm also giving it a service. So now we have our memcache running and our MySQL. So that is great. Doesn't bring us anything right now. Nothing is working really. So if you look. The next thing that we want to do is we actually want to bring up our front end. So the first thing, and we will look into that, is our front end replication controller. So again, we went already through like API version 1, what type is this configuration file describing in this case, the replication controller. And I attached a couple of labels. I also attached a version here in that label, and we will see later like what for I will be using that. I describe like how many pods do I want to run of the container that I describe later in this file. And in this case, I want to have actually three instances of that pod running. And further down here, I describe the container that I'm running. And this container I built myself. I pushed it to the Google Cloud container registry, which you will get if you sign up and create a project. You can create your own container repository where you can push containers to. And I'm also saying like I expose port 80 on a TCP protocol. All right, so kubectl again, and we're creating the front end replication controller. And you see here, okay, it actually shows up, and now the web page is a little. So basically, you see like the three pods were spin up. They are controlled and managed by this replication controller. And that replication controller is only responsible for version 1 of these containers. And we also see they are talking to memcached and MySQL. So if I would be now inside of this cluster, I could access already these pods. I can find out the IP, but that's like very cumbersome. So I actually want to, again, I want to have a service which exposes an IP. So I create a service as well. And this service is actually special because this service, on the one hand, is creating the normal, or the service that you see for Memcached and MySQL, but it also will add an external IP address. So if the demo gods are good with me, I should see the external IP address coming up. But I also can use the command line. So let's go back on the top and can say, okay, kubectl describe service, and this is front end service. So it shows me, okay, I have an IP and I didn't get an external IP yet, so I hope that it's coming up unless it's, let me see if the front end service YAML is correct. Looks good. So it should give me an external IP address. It should. Demo gods, please. Alright. Bear with me. I will try one thing. If I don't get that running, I unfortunately can't show the other things, which would be very, very sad. So let me try this. And we create it again. Create master front end service. All right. I guess the demo gods are not happy with me today. All right, so unfortunately I can't show you the guest book now because I'm missing the external address. But what I want to show you anyway is what you can do actually in terms of rolling update. So imagine you would have seen the guest book, and I posted to that guest book. You would have seen a guest book with a white background. And now I say like, okay, I don't know like why it is like plain, it's timeless, yes, but I might want to see like if a different background color attracts more people to my guest book. So I want to do some, the external address came up. Okay, awesome. So let's stop imagining here and actually see it. Yeah, obviously. Yeah. Yeah. Okay.
Better in my head.
Okay. No. Oh. So let's see. Okay. Yay. Okay. So you see, you have some test data. Hello. Swansea. All right. And we submit. Okay. Awesome. So the guest book works. Now, I mentioned I want to do something, I want to have a different kind of background color. So I go in my PHP guest book and I go in my index HTML and actually do some style and then color. And because I want to use a special color, I actually have my cheat sheet here and add that. Looks good. Any typos? All right, confirmed. Okay, good. Oh, yes. Yeah. Okay, good. Okay, so now I do my rebuild and I actually say, okay, that is version 2 for me. Oh. That happens if you restart your laptop. So actually what this rebuild script here does is we are using the Docker toolset and facility to build the Docker container, and then with the updated index HTML. And then we push, once we have built this container, which basically packages our new app with our new color, it pushes this to Google Container Registry. So to be able to do that, I run boot to Docker on my Mac. And let's see if that did the trick. Looks good. So we're building the container and we're uploading it. Let's see. Let's hope the Wi-Fi is strong. And actually, I did build that container already, so it shouldn't be any different. Let's see. Oh, it's actually pushing something. Ooh. All right, so now we have version 2. Okay, so now what we do now is we create a different front-end replication controller where we say, okay, I want to now run with this replication controller version 2. And let's start with one replica. What that basically means is, so I start again, kubectl create -f front end rc v2, and we will see version 2 coming up hopefully. So you actually see here we have another pod with version 2. So right now what is happening is actually what you can do with that, with this facility, is that you run your new version of application and basically split the traffic. So you kind of test, like, how is it received? How well will it be received? And as you can see, we defined actually the front-end service to only pick pods this service is servicing by the name label. So basically it's labeled as like checking for front-end, and it's serving all front ends, right? So if I now refresh my site often enough, let's hope it's in the first 10 times, and otherwise I have to trick the system a little bit. There should be a blue one coming up. It's not coming up right now, so we will actually reduce the number of replicas. So I hope that is the right command. Scale. And v1. Okay, I have to cheat again. Commands. 1 second. All right, almost correct. Okay, scale, and then all right, so now we see, okay, we have two running, two versions, so 50% of the traffic now should actually go, and we see, okay, our blue one. Okay, let's, I tested my version, and it's okay. So I actually want to do, so I scale, actually, we start with scaling that back to 3, our initial version, so our version 1. And then the next thing that I do is I actually want to delete my relation controller and do front end RCV2. Oh, of course.
Isn't it V1?
No, in this moment I actually want to. So that's So let's see, like what, like that are the nice things you can actually list, like what replication controllers you have, but the other way around. What's happening? Not list. Sorry about that. So this shows you all the ones that are running, and it's actually like this. Okay. So you're back to version 1. So we should see only the wide version. Okay. And now what I want to do is a rolling upgrade. So I tested my version 2, and I actually want to do a rolling upgrade. So I show you again the, you see here we have 3 instances of version 1 running. And let's do the rolling upgrade. So rolling up date, front and V1. Minus F, front and V2. C2. And we giving the update period. That's basically grace period between pulling down pods and starting new ones. And I put that for now to 2 seconds. So what does it do is basically it's looking at, okay, what is the old version, what is the new version, and it should come up soon that we are rolling basically out. So we are rolling in version 2 here, and then we slowly rolling out the version 1. So while we are doing, we should see still the white and sometimes blue coming up. Okay. Actually did the rolling upgrade, so I didn't do a change in the configuration file, so we only have one version of the V2. All right, so this be it for the demo, and I would be open for any kinds of questions if you have any. So you would do that basically in your application. So you would basically do logging, right? So for the cluster that is running on Google Container Engine, that's integrated with our cloud logging service. So basically, you could do analytics on the cloud on these like logs that you're logging to see like how many, like how long are these sessions, or how long do people stay on your pages, or stuff like that. So you have to find your own metrics that you want to choose to select like which version works better. So you can kind of see like, okay, where are people exiting, or do they easily find a path? So like, for instance, if you have a new version with a new navigation pattern, you see if people are more likely to go to certain pages or things like that. And for that, you can also stream the logs into BigQuery, for instance, and do your analytics on BigQuery. So in this case, like if you look at the cluster, basically the service that we created has one stable IP address to the outside. So that is the IP address that all the traffic would come in. And this service, we defined it to basically go only after the front end pods, which meant like it didn't matter like which version of the front end pod, it's like distributing to all the versions. Yeah.
So Kubernetes is in use and has been in use for some time in Google.
So basically, Kubernetes is inspired on how we run containers at Google. Basically, we took all the lessons learned throughout the last couple of years or 10 years that we are running containers. We took all the lessons learned and wrote Kubernetes from scratch, new. So it's not something that we have taken out of like production from Google, but we took all the lessons learned and put it into Kubernetes. Yeah. So security and isolation, in terms of security, is still a topic that is heavily in development. So it's a known fact that there are certain scenarios where you can break out of a Docker container. Kubernetes is not there to solve this. Basically, we depend on the container system formats that we schedule. But basically, there are like initiatives out there to also like part of these foundation, I believe, there's a new open standard container format that is in the works, which wants to address certain of the shortcomings from Docker, for instance, right? The other container format that is like developed out there is Rocket, which is from the CoreOS guys, for instance. So it doesn't address like security in that perspective, but you have a lot of other things. So to address security, what we are currently doing is you get your own cluster, right? You get your container cluster. And that container cluster is basically a bunch of virtual machines. So if you trust your containers that run in this cluster, then you basically safe to some extent. Basically, there are no rogue containers running from other customers of Google in your cluster, right? So if you trust your organization and that nobody tries to do harm and to be evil, then you can still use it, right? But of course, at some point, we want to get to a state where we actually have the isolation, like security isolation, even on your Docker containers in a way that we can provide Kubernetes as a service in a way where you say, okay, I want to schedule my container, but I don't want to take care or want to bother with setting up a cluster and defining how many nodes I want to have in this cluster. I just want to run a container. I just want to run a workload, right? So at some point, if we like somebody out there solved all these problems, we will probably see Kubernetes as a service.
Does it help with things like zero-day exploits, things like that, where you can roll in updates faster across the whole platform, or is it not flagged?
So basically, it helps you. Like there are certain constructs. Like the question was like, does it help with exploits, like running out?
Yeah. So like for example, if somebody discovers flaw in some
Yes.
software.
Yes.
Because obviously the containers are versioned on that level, you
Yeah.
can roll that out without breaking everything else. Or how do you
Yeah.
manage conflict between containers?
Yes.
So
So basically that is what I showed with the rolling update. So you basically what you would do is a canary. You would like deploy one container, see if everything works, if like there are any new problems coming up, right? And then once you verify that this container runs like flawlessly in your environment, you basically do the rolling update, and you can do that. You can define how fast you do that. So sometimes certain things don't show up when you run one container or two container. We see that sometimes, rarely at Google as well, that we are all like doing this. We are running new versions of software, and like for a certain percentage of the user of for instance, search or maps or stuff like that. And to see if there are any new like regressions coming in or any new problems coming in. Most of the problems we can catch by doing that. So we can see like, okay, there's something going wrong, we fix it, and then if everything's fine, we just roll it out through the entire fleet. And we usually do that in waves, right? And why we're doing that in waves again is sometimes certain issues you only see at scale, right? So you see it like, okay, you don't see it when 10 instances running or 10% of your traffic goes to the new version, but you suddenly see it if 50% of your traffic goes to this new version, right? There might be some like rogue API calls that are going through the air and suddenly bringing down firewalls or stuff like that. So you want to do that in waves, but it definitely helps you with that because we basically manage on container basis, so we can just do a rolling upgrade and get the new version.
Parameters as to who you want to send specific versions of it to. So obviously there it was random.
Yeah. So currently basically the load balancing on the service load. So the question was what are kind of parameters to like route the traffic to certain versions of your pods in your. So currently the scheduling or the load balancing on service level is very basic. It's basically around Robin load balancing. You can define a session affinity as far as I know. So basically if one user got routed to a certain pod and he capes the session, then he will always be routed to that version. That saves you basically. Sometimes you have some setup code that you need to do for a user, or you need to load some data from a database, so you don't want to do that for every call, of course. So you have ways to, once your user came once, to route him always to the same pod and only reroute him when the pod dies. So this is possible, but you don't currently have any other ways to say like, okay, I only want to have my users from the UK, 10% of them going to that pod. So there might be something in the work, but I'm not aware of if that's to what extent that is possible. Yes.
Marcus, any question? Do containers suffer from orphan processes?
So the question was, do containers suffer from orphan or like zombie processes, right? So the thing is, like the credo at containers is basically run one process per container, right? And as soon as this process, like to some extent, breaks or goes rogue or like stops, this container is basically killed and a new container started. So you basically watch like the healthiness of that process. So there might be like orphan or zombie processes. I'm not aware of it, and I couldn't give a definitive answer. So I haven't seen it.
And the janitor function that ties things up.
Yeah. So basically. You do like certain health checks against the process if it's still living, and if it doesn't, you stop the container and restart a new one. The Kubernetes gives you also possibilities, and Docker to actually go into these containers and see what went wrong. So you still have the file system is preserved to some extent. So it's not like it's stopped and it's like instantly gone. You can do some post-mortem analysis what went wrong in your container if it should break down.
That's that health check. Is that just at a container level, or can that health check dig into the service or the app that's running within that container?
So basically what Docker does is basically on the container level, but you can also do, so currently the services is basically doing using Docker for health checks. You have other facilities. If, for instance, if you want to do scaling or stuff like that, you can plug in with cloud monitoring and service from us that can actually inspect other parameters. So you can check like, is your service still alive on port 80 or on port 443, or is it still returning the data that I expect to be returning on certain ports? So yes, you can hook in there, but it's not, as far as I know, not used for the health checks of the services. That's really the basic health check.
What does a good sort of team development methodology look like with this? I mean, obviously you've got rapid release cycles available on this.
Yeah.
So what's the best way of working a team around this?
Yeah. So question was, what's the best way of working in teams with using something like that? So I would say in general, like if you work with Docker containers, it doesn't differ very much from the Kubernetes. So Kubernetes gives you basically an infrastructure where you can run your setups, and you basically use labels to separate your environments. So basically what you could do is when you're a developer, you put in your label, which is like unique for your user, and then you basically run your own. Of course, things can go wrong, and you don't want to interfere with production or stuff like that. So if you,
how does Google do it?
I don't know. I honestly don't know how Google does it, but basically there's measures within Google to make sure that like workloads that we are running are bound to the user basically, and they're restricted in terms of the resources that they are allowed to consume. So, but basically, if you look at Kubernetes, usually the good practice right now is still, it's version 1. It will improve, but right now it's like if you run your production, you should run that in an isolated cluster, and then you can run testing, staging, and development in a second cluster, unless you're really good in keeping separation between your workloads. But then it like shouldn't happen that you accidentally, I just killed the production MySQL. right? So I haven't looked into like what are the security measures in terms of who's allowed to do what. We are not at that stage. Like we cannot say like, okay, users, these users are allowed to manage these replication controllers, or so the security concept on that level, I'm not sure how that looks like right now.
And how do you stop people spinning up things that consume huge amounts of resources?
Yeah, so basically you currently you stop them by running out of resources. So like, again, that is the whole like security level in terms of user management on Kubernetes. So I have to admit that I might be wrong there, that this doesn't exist currently, but I haven't seen it. So I might have just missed it or worked not enough with Kubernetes, but I haven't seen resource management on user level, so that you basically can say, okay, this user is authenticated or is authorized to do this, and he is authorized to use that much resources. So as soon as you introduce that level, then you can basically like restrict the resource consumption, like by user, for instance.
Because I know in LinkedIn they had a problem with Hadoop Stack where people were just being very creative with the kind of jobs they were running.
Yeah.
And in one case, I think one guy was, because his job was running slow, he shut down everyone else's job so it could run faster. There was no security level. And so one of the things they brought in was when the job ran over a certain time, they had a time limit and kill it.
Yeah.
But if that's something that's similar, I mean, obviously it's not time limit, but the resource consumes more than what it's allowed to, then maybe shut down. Is that something?
Yeah, I mean that it's so basically for on pod level you can restrict the resources, right? We saw it on the configuration file. On pod level you can basically say, okay, this pod is allowed to like reserve that much resources, and by that you cap basically and say, okay, if it like exhausts that these resources, then it's done. So you can restrict the resource consumption on pod level. Which helps you to some extent, but basically user could still go in and say like, okay, I want to have everything that's available. And then again, so basically that is like put on the user responsibility to manage that currently. And comment to like killing everybody else's jobs or pods, don't be evil. Yeah, one of the creators at Google. All right. Thank you very much, everybody. So, like, for holding out. I think like that went a little longer than expected, but thank you for staying with me. And yeah. One last thing, if I find my slides again. So I have 60 coupons in the value of $200 that you can get from me. Oh, no, okay. Awesome. So I have just to find the slide. But basically, I have the... let's see if that's right. No. Okay, I will find the slides. But basically, I give you a link where you can sign up and claim the $200. I will send you an email with the code. And I will, while Phil is speaking, I will find the slide.
Right, so that's it for the talks now. The only thing left is to set up the hackathon tomorrow. So can I just get a show of hands, everyone who's going to be in here tomorrow for the hackathon? Fantastic. Right, so keep your hands up if you're not with the DVLA. Okay? So, there we go. Right, DVLA guys, I know there's 15 of you now, and I know you want to go into teams. Well done. 5 per team is a maximum, so you want 3 teams from you.
That means 3 ideas.
3 ideas. But you've had since last week to come up with ideas now.
Yeah.
Right.